Alright, ladies and gentlemen, 5.4, we are still adding and subtracting rational expressions, but this time we have unlike denominators, so it's going to be a little bit more challenging for us. So we need to write out our steps first, because there are a few steps to this. What we have to do first is find a common denominator. Another term that we use for common denominator is least common denominator, so LCD. Okay, we're going to be using LCD throughout the unit, or least common multiple, same thing. After that, remember, just like finding common denominators in regular numbers, we're going to multiply each term by the term that will give the common denominator. So we want to make sure that we multiply the numerator and the denominator. And then it's not too bad. We want to add and subtract the numerators, simplify if we can. Alright, example 1. 3x squared plus 5, or over 5, plus 4x squared over 15. What we always want to ask ourselves is, do I have common denominators? Look at your denominators, 5 and 15. Are those the same? No. What would the common denominator be? 15. So what do I need to multiply the left-hand side by to get 15? 3. So multiply the top and the bottom by 15. Do I have to change the right-hand side at all? No. So that's going to give me 3 times 3x squared is 9x squared over 3 times 5 gives me 15. The right-hand side got to stay the same, so 4x squared over 15. Now we get to put the whole thing over the common denominator, which is 15. 9x squared plus 4x squared gives me? 13. Excellent, 13x squared. Can I reduce the 13 and the 15? No, so that's your answer. Not too bad, right? Okay, thumbs up, thumbs down. It's only the first example. It doesn't get much more difficult than this. Okay, example 2. 6 over 8x minus 3 over 6x. Okay, so I'm looking at this problem. Both of them have x's, so they already have that in common, but the numbers are different, 8 and 6. So what would my common denominator be? 24 x. Both of them already have the x's, so we're good there. So what is this one missing? What do I need to multiply by to get 24? 3. So multiply top and bottom on the left by 3. What is the right-hand side missing to get 24x on the bottom? A 4. So multiply top and bottom by 4. So watch what happens. 3 times 6 gives me 18 over 3 times 8x, 24x, minus 3 times 4 is 12 over 6x times 4, 24x. Now I have common denominators, right? Okay, so I can put the whole thing over the common denominator, 24x. 18 minus 12 gives me 6. Is that my final answer? No, I can reduce. 6 and 24 both reduce by what? By 6. 6 goes into 6 once, and 6 goes into 24 4. So that's going to give me 1 over 4x. That 4x has to stay in the denominator. It does not go anywhere. So it stays in the denominator. On top we put a 1 as a placeholder. A little bit trickier. Example 3. We have 4 over x squared plus 3 over x. Hold on. No. Okay guys, look at our denominators. Here I have x squared, and here I have x. What would my common denominator be? X squared. Do I have to change the left-hand side at all? No. What do I need to multiply the right by? By an x. So multiply top and bottom by an x. You have to multiply the top and the bottom. So that's going to give me 4 over x squared plus 3 times x, which is 3x, over x squared. Put the whole thing over the denominator, x squared. Okay, and then we add 4 plus 3x. Are those like terms?
No.
So can I add them? No. We do like to put the x's first, so on top we have a 3x plus 4. You have to leave them separate. They're not like terms. Can I reduce the x and one of the x's here? No, why not? Because they're stuck like glue with that addition. So that's your answer. Uh-oh, stuck like glue. You guys can sing that if you want. Yeah, I know. You and me, baby, we're stuck like glue.
Actually, I'm a song.
Are you recording?
Yeah.
Like an actual song?
Yeah, so go watch the recording and you will hear me singing. Yeah. Example 4. Example 4.
We have 5
Last example.
No. 2 over x minus y over xy. What is the common denominator? xy. So what is this guy missing? A y. So multiply top and bottom by y. Y times 2 gives me 2y over xy. Minus, was the right hand side missing anything? No. So y over xy. Okay. We put the whole thing over the common denominator, xy. What's 2y minus 1y? Y. Am I done?
No.
Yes.
No.
Genevieve, will you say that again nice and loud? Because your explanation was perfect. I could not have said it better. Go.
The y's cancel out because it's multiplication.
Yeah. The y's cancel because it's multiplication.
I knew it.
So, hold on. This is the most important part because this is the most missed thing on this type of problem. Where is the x? On the bottom. So does it move to the top? No, it has to stay in the denominator. So what do we put on top? 1. You guys are brilliant. Okay. Last one.
So you got at least starting to sing it.
Example 5. 3 over 4x plus 5 over 8. Ladies and gentlemen, take a look at this. These are obviously not common denominators, right? Okay, so this is the trickiest one. What is the common denominator? Don't say it out loud. Turn to your neighbor. Tell them what it is.
I don't know. She's gonna check in her head. I know. It takes me a while.
Who's 15? Aaron. Guys, what is the common denominator going to be?
8x.
Yes, 8x. Everybody give me a round of applause. Okay, ladies and gentlemen, everybody at the same time. Why is it 8x?
Because.
Okay.
Go ahead.
Yeah.
You have to multiply by 2.
Yeah, this one has an x, so the denominator has to at least contain an x because they have to be common. And so then we look at the numbers 4 and 8, and what's the smallest number that both of those can go into? 8. So guys,
I suck at math.
okay, 4x, what am I missing to get 8x? Times 2. On the right-hand side, I already have an 8, so what am I missing? X. So that gives me 6 over 8x plus 5x over 8x. So we just multiplied. No. Put the whole thing over 8x, and then look, I have 6 plus 5x. Those are not like terms. So it's 5x plus 6.
You can.
There's no GCF. You can't reduce the 6 and the 8 because these guys are stuck together. So you are done.
Can't we just do 6